In this video, I want to define a sample space and give some examples of sample spaces as well as events. Let's start with that of a sample space. A sample space is all of the possible outcomes of a given probability experiment. So it's all of the things that could happen. And traditionally, a sample space is just denoted by the letter S. Let's look at some examples of this. My first example, I want to give the sample space of the experiment that selects a fuse and classifies it as either defective or non-defective. So we denote this by S, and we use the curly braces to list out our sample space. And there are two possible things that could happen. It could be classified as defective, or it could be classified as non-defective. So this is our entire sample space for this particular case. Next, I want to give the sample space of the experiment that selects two fuses and classifies each as defective or non-defective. I'm going to abbreviate these by D for defective and N for non-defective. So this time I'm going to select two fuses. So they could either both be defective, they could both be non-defective, the first could be defective and the second one not, or the first not and the second one defective. And it's really important to notice here that order is important. DN is different than ND. This time, I want to find the sample space of the experiment that selects two fuses and records how many are defective. So instead of recording the state of each one, we just want to know how many are defective. It could be that neither are, it could be that one is defective, or it could be that they are both defective. So the sample space would consist of 0, 1, and 2. I now want to give the sample space of the experiment that records the number of fuses until the second defective is found. Well, we would need to select at least two. In this case, the first one would be defective and the second one. After we've picked two, if we've only found one defective, it could be 3, it could be 4, and this could keep going indefinitely until we find the second defective one. So we would have the integers that are larger than or equal to 2. My next example, a student is selected and their opinion about a proposal to expand the use of solar energy is recorded on a scale from 1 to 10. I want to describe the sample space of this experiment. Well, the student could have selected a 1, a 2, a 3, etc., all the way up to 10. So here we would have all of the integers that are greater than or equal to 1 and less than or equal to 10. This time, we have 3 students that are selected, and their opinions about a proposal to expand the use of solar energy are recorded on a scale of 1 to 10. So I want to describe this sample space. This one's going to be a little bit trickier. Before I write it down, let's think it through. I'm going to consider these as ordered triples. I have 3 students, so I'm going to do each of their scores in one of the spot. Maybe they all said 1. The first 2 said 1, the second one said 2. The first 2 said 1, the second one said 3. We can continue down until we have the first one said 1, second one said 1, and the third one said 10. It could be that the second one said 2. The second one said 2, the third one said 2. And we can kind of continue this process down. And eventually what we get is all of the ordered pairs ABC such that A, B, and C are integers, and they need to be between 1 and 10. So we end up with all of these ordered triples where all 3 of the entries have to be an integer between 1 and 10. Very much related to the definition of a sample space is the definition of events. Events are collections of individual outcomes. So let's go back to our example where we had a single student that could do ratings on a scale of 1 to 10. So we could have an event that says a low score, that of 1, 2, 3, a medium score of 4, 5, or 6, or a high score of 7, 8, 9, or 10. So these would be 3 different events that we could consider.